Welcome to the world of chemistry. In this video, we want to talk about alkane. Alkane as group of organic compound, the first 10 member of the alkane homologous series, preparation of alkane, and properties of alkane. Alkane is a group of organic compound. As a matter of fact, saturated organic compound, an hydrocarbon, with general formula CnH2n plus 2. Yes, I said saturated organic compound because its functional group is single covalent bond, and an hydrocarbon because it consists of carbon and hydrogen only. Carbon and hydrogen only, and that is why we call it an hydrocarbon. General formula CnH2n plus 2. So when n is equals to 1, when n is equals to 1, we have the molecular formula as CH4, that is 1 carbon atom, then 2 times 1 making 2 plus 2, 4. And when n equals to 2, we have it as C2H6, 2C2, 2 times 2 making 4 plus 2, 6. When n equals to 3, we have C3H8, and so on. Pause a bit and try to write out the first 10 members of alkane homologous series. That is, you continue from here and say when n is equals to 4, when n equals to 5, when n equals to 6, when n equals to 7, when n equals to 8, when n equals to 9, and when n equals to 10. I can help you out with when n equals to 10. When n equals to 10, say C10, H, 10 times 2, 20, plus 2, 22. When n equals to, so, like I said, pause for a while and quickly do this. I want to believe you have done that with this molecular formula. Then the next thing is to put the name. This we call methane, ethane, propane, butane, pentane, enzene, heptane, octane, nonane, and decane. These are the first 10 members of alkane homologous series. Right? From there, we move to preparation of alkane. Preparation of alkane. Remember in characteristics of homologous series, we say one of the characteristics is they have the same method of preparation, which means the same method you use to prepare the first member of that homologous series is what we use to prepare other members of that homologous series. What we are saying is the same method used to prepare methane is what we use to prepare ethane, and so on like that. So let's pick methane. Preparation of methane. There are many ways to prepare methane in the lab, but one of the easiest ways to prepare methane is in the reaction of sodium ethanate with soda lime. That is, sodium ethanate in the presence of calcium oxide to dry it. This in solid state, this in solid state, to prepare methane or sodium carbonate. Yes, these are two reactants, that is sodium ethanate and sodium hydroxide. You react them together, the mixture together, you heat it up. Yes, in the presence of heat, you heat it up to give methane as a gas and a sodium carbonate in solid state. This is dry over calcium oxide. Thank you. Yes, going to preparation or reactions of alkane. reactions of alkane. Basically, there are two major reactions of alkane, and these, the first there is combustion. Combustion of alkane. By combustion, we mean reaction of substance with oxygen, that is burning of substance. So let's combust the first member of alkane homologous series. Generally, all alkane will undergo combustion depending on the quantity of oxygen available. In the presence of sufficient oxygen, carbon dioxide will be formed. In the presence of insufficient oxygen, which we call incomplete combustion, then there is possibility to get carbon monoxide or carbon, depending on the condition of the reaction. Yes, combustion of methane. Plus oxygen to give carbon dioxide and water. This is when there is sufficient oxygen, sufficient amount of oxygen. If there is no sufficient amount of oxygen, then CO will be formed, that is carbon monoxide or carbon, as the case may be. Yes, let's try to balance this equation. There are 4 atoms of hydrogen here, which makes this to be 4. Yes, there is only one carbon atom. From the product side, we have 2 atoms of oxygen here plus 2 atoms of oxygen here, making 4, and that makes it to be 2. So this is in the presence of sufficient oxygen. If you try to combust the third bond of alkane as well, C3H8, yes, in the presence of oxygen to give carbon dioxide and water. Yes, let's try to balance that. 4 here, making hydrogen to be 8. Then there are 3 carbon atoms, 3. Oxygen here, we have 6 plus 4, making 10. And that is 5 times 2, 10. So this is how you balance your reaction for combustion reaction in the presence of sufficient oxygen. Yes, this other reaction is what we call substitution reaction. Substitution reaction. Substitution reaction of alkane. Yes, alkane generally undergoes substitution reaction, and by substitution reaction we mean reaction that involves the replacement of atom of central carbon. When you have carbon like this, for example, with its tetravalent electron, yes, these hydrogen atoms that are displayed by this central atom will be replaced by another atom, and this we call substitution reaction. Under this substitution reaction will take place under certain conditions. Yes, let's keep methane, for example, CH4 plus an halogen. For example, let's pick chlorine in gaseous state, in the presence of UV light, which means this reaction may not proceed as expected if there is no light. Okay, and what will you form? You form one of these hydrogen atoms will be replaced. So you have CH3 instead of 4, which means one of these has been taken over by this chlorine, and you get HCl here. HCl in gaseous state. This we call monochloromethane. This monochloromethane, you still have 3 replaceable hydrogen atoms there. CH3, Cl, which is in gaseous state, plus chlorine gas, the same condition, light. Okay, you have CH, one of it being replaced, 2Cl2, yes, plus HCl. This in liquid state, this in gaseous state. Okay, this we call dichloromethane. This one, you still have 2 replaceable hydrogen atoms there. Chlorine, the presence of light, that is UV light. Yes, this will be replaced and you have CHCl3 is a liquid state plus HCl. Okay, you still have one replaceable hydrogen atom there, CHCH3, which is in liquid state plus chlorine, and this in the same condition, light, UV light, then to give you CCl4, which is in liquid state, and this here in a gaseous form. Yes, this is the complete substitution reaction of methane, which means when one atom of hydrogen is replaced, we get monochloromethane, 2 replace dichloromethane, 3 replace trichloromethane, and the whole 4 carbon atom from methane replaced to give you tetrachloromethane. All these products are of essential usage in chemistry, like tetrachloromethane is an organic solvent, trichloromethane, generally known as chloroform. It is used as an anesthetic and so on like that. In our next video, we'll look at how to balance combustion reaction, the general equation to follow and the pattern, so as not to stress you during examination. Thank you.
If you found this video educative, please like, comment, share, and subscribe. Thank you.